Iceland became the first country on Earth to use more electricity mining cryptocurrency than powering every home in the nation. Every house, every apartment, every kitchen light, outpaced by server racks running cryptographic equations around the clock. That's not a projection, that's already happened. But the part nobody talks about is how Iceland pulled this off without burning a single barrel of oil to do it. In the next few minutes, you'll see how a small island of 370,000 people turned raw geological accident into the world's most unlikely energy advantage, and why the global AI industry is now racing to follow. Iceland doesn't generate renewable energy, it is a renewable energy source. Roughly 30% of the country's electricity comes from geothermal power, heat drawn directly from volcanic activity beneath the island. The rest comes largely from hydropower, fed by glacial rivers. The result is a grid that produces more clean electricity than the country can easily use. That surplus is the key detail. Most countries fight over energy scarcity. Iceland has the opposite problem. And when you have cheap, clean electricity with nowhere to go, industries that devour power at scale start looking very attractive. Bitcoin miners noticed. Cryptocurrency mining is, at its core, a cooling and electricity problem. The computers running these operations generate enormous heat and consume staggering amounts of power. In most countries, that means sky-high energy bills and a heavy carbon footprint. In Iceland, it means neither. Magma sits close enough to the surface that engineers can tap it like a faucet. That geothermal heat gets converted into electricity, cheap, stable, and clean. Researchers have assessed geothermal energy as one of the most cost-effective and environmentally friendly options for Bitcoin mining compared to most alternatives. You're not burning coal or gas to power the rigs. You're tapping heat that has been sitting under the Earth's crust for millions of years. Then, Iceland's climate does the rest. Arctic air handles a significant portion of the cooling load that would otherwise require additional energy infrastructure in warmer countries. For Bitcoin miners who had watched energy costs soar and regulatory pressure mount in the United States and elsewhere, Iceland was the rational answer. Cheap power, cold air, clean grid, no compromise on scale. The island became a refuge. Here's where the numbers start to reshape the story. The data center sector, which includes crypto operations alongside other server infrastructure, now represents 5% of Iceland's total national energy use. That figure is climbing. And the country's grid, built on volcanic heat and glacial rivers, is absorbing that demand in a way that almost no other nation on Earth could manage. Then AI moved in. The same properties that drew Bitcoin miners, surplus renewable electricity, cold ambient temperatures, stable infrastructure, make Iceland equally attractive for the data centers running large language models and AI workloads. Iceland is on an upward trajectory as a destination of choice for AEI server farms. The global race to build AI infrastructure has a problem most people don't discuss openly. It consumes enormous amounts of power, and most of that power isn't clean. Iceland offers a rare alternative, a place where you can run energy-intensive compute at scale without the carbon cost that comes with it almost everywhere else. The 5% share is a signal, not a ceiling. A country of 370,000 people crossed a threshold that no other nation had reached. More electricity consumed by crypto mining than by its own households, and did it with near zero carbon emissions. That fact is now being studied by energy planners far beyond the North Atlantic. Because the global AI and crypto industries are growing faster than clean energy infrastructure can keep pace with in most parts of the world. Iceland's volcanic grid is a proof of concept. It shows what becomes possible when geology and technology align at exactly the right moment. The real question the industry is sitting with isn't whether Iceland's model works. It's whether there are enough places like it to sustain what's coming. Right now, there's only one island sitting on a magma field big enough to answer that question, and it's already running at full speed. Iceland didn't set out to become the world's crypto capital. It set out to use what it had. Volcanic heat, glacial rivers, cold air, a surplus no one else wanted. The rest of the world built its energy systems around scarcity. Iceland built its around abundance. And that difference is now shaping where the internet's most power-hungry infrastructure gets built. If you want to go deeper on this story, the full article is live at factstormhub.com, And if you want more stories like this one, the kind where geology, technology, and economics collide in ways nobody predicted, subscribe. We publish these every week, and the next one is already in the works.